Hi class, welcome back. Here I'm making a quick video to show some of those practice problems from the lecture 5.4. So I'll start with practice problem number 4. Let's find the relative extrema of this function, x times e to the x. I remind you guys that to find the relative extrema, you need to find the critical numbers. And then in this case, I'm going to use the second derivative test to determine whether I have a relative max or relative min. All right, I hope you guys enjoyed this. The derivative of this, well, if we notice, first of all, that this is going to give that this is a product function, right? This is a function of x times a function of e to the x. So if you guys are thinking about product rule, good job. We need to use product rule to find the derivative of this. And sort of that's what I did, right? So I took out the derivative of the first one, and then times the regular second one plus the first regular function times the derivative of the second one. The derivative of x is 1 times ex, and then the derivative of ex is ex. So if you guys notice, and this is sort of kind of like the rule of thumb, when you guys are doing this and you're trying to find the critical numbers, please factor the e to the x. It will make everything much easier, right? We usually try to factor this as much as we can. You should try to factor the e to the x, right? And that's what I'm going to do. I'm going to factor e to the x, and I'm left with 1 plus x. And now, to find the critical numbers, this will happen whenever the derivative is 0 or whenever the derivative is undefined. Now, because this is a exponent, this is going to be continuous everywhere, and this is a polynomial. They're both continuous everywhere. So when you multiply two continuous functions, then they're always going to be continuous everywhere. So there's no place where this is going to be undefined. So we're going to move on with this part over here. Now, one thing that we want to remember is that if you are using, when you're setting this equal to 0, you're setting this every factor in equal to 0, right? By the zero factor property. Now, when I set this one equal to 0 and then this one to 0, we're not going to get anything from here because e to any power is never going to equal 0. Remember that as x goes to negative infinity, it approaches 0, the exponential approaches 0, but it never actually gets to 0. So there's no 0 here, ever. So any exponential to any power will never equal 0. I hope that's clear. Then we're going to move on to the next one. We're going to set this equal to 0. So for x, and that gives us negative 1. I ended up taking the second derivative because I'm going to use the second derivative test. So I found out the second derivative of this by looking at this one right here. And I did the derivative of the first one, which is going to be that part. And then for this, I have to use product rule again, right? So I'm just using the same approach that I did in the first derivative. So it'll be x prime times e to the x plus x e x to the prime. The derivative of ex is ex, and then this will turn into a 1, and then this will turn into ex. Now, if you guys notice, those two are common factors, common terms, so like terms, sorry. So we can combine them, and that'll give us 2ex plus x to the times e to the x. Now, I can easily just factor the ex again. That leaves me ex times 2 plus x. And now I'm going to test my number, right? I'm going to test my critical number. So I'm going to plug it into the second derivative. And then what do I get from here? Well, e to negative 1 is 1 over e. 2 plus negative 1 is 1. So obviously this is going to be positive, right? Because e is always positive. E is 2.71. So e by itself is always positive, right? In fact, e to any power is always positive. So e to the x by anything is always going to be positive, except if there's a minus in front of it, right? But overall, e to the x is always positive. If there's no coefficient in front of it, that coefficient is going to make it negative if it's negative. So anyways, that's positive. So that means that this is concave up. So that means that this is a minimum, right? You're going to find a minimum at x equals negative 1. Now, I noticed this in the test. Some of you guys made this confusion. You guys were confused in this part This is not the minimum value. This is where you find the minimum value. To find the minimum value, you actually have to plug it in back into the original function and find the corresponding y value of it. So plugging -1 to the original function, you guys can kind of see the original function is x to the x times e to the x. So -1 e to the -1, and that gives us -1 over e, which is this is your minimum value. All right, we'll try practice number 8. Practice number 8 is asking us to find the integral, the antiderivative of 5 times x times e to the -x squared. So in this problem, I approached this with u substitution. So the reason why, and that's sort of kind of like the rule of thumb, is whatever, if you have an exponential function in your in part of your integral, the most likely this will be your inside. This will be your inside, most likely, right? So that's, I'll say, almost 90% of the time. All right. So so let this be your u. That should be your first sort of trial, and then double check that when you take the derivative of this, it's sort of part of a product. So the derivative of this is -2x. We don't have the -2, but we have the x, and that's good enough. Remember that we can be just good enough with as long as is a multiple, scalar multiple of it. All right, so I let that be my u. Then I took the derivative of this. This gave me -2x dx. And then sort of this approach, I did it like by dividing -2x on both sides, so I can isolate my dx. So you guys see what dx will equal to. It's going to be du over -2x. So I replaced, I moved the 5 outside. Then we have the x e to e to the u, and then I replaced dx with du over -2x. And then what I did here is I just cancel the x with that x, and I move this -2 to the outside factor. But because it is a denominator, it has to stay as a denominator, right? So I use the u substitution now. Everything looks good, right? Everything is fine. And then now I'm going to apply the integral. Do you guys notice how we first got to set up the u substitution before we can take the integral? And then we're going to take the integral of this. The integral of e to the u du is eu plus c. Don't forget about the factor. And then we're going to go back and replace u with -x squared, right? Because that was what your u was. And then and plus c. So we found our value, right? I found the integral. Okay, so we're going to try another practice number 9. In practice number 9, it's asking us to find the antiderivative of two problems. So we'll start with part A. Find the integral of e to the 1x over x squared. So again, as I mentioned before, try to make your power of the exponential be the u. So if you let that be u, sort of like your educated guess, then that's gonna be 1 over x, which is x to the -1, right? When you take the derivative of this is gonna give you -1 x to the -2 dx, right? You have to bring down the power and subtract 1. And then if you set this up, right, this is going to be the same as du minus dx over x squared, right? Because it has a negative power, you're going to bring it down. If you notice, that's sort of it's already there, right? It's already there. So you have, this will be the u. If you notice, dx over x squared is sort of what we already have here, right? So du is almost this, right? Except that we don't have that negative that we have here, right? So I'm going to do this in a different approach, and you should be comfortable with doing both of them because both of them are sort of kind of neat. I feel like once you understand both techniques, you really understand the u substitution process. So in this case, instead of isolating dx, I'm going to do it the way where you just multiply by -1 the function, and then you compensate by multiplying the outside, right? Negative times negative will become positive, so you're not actually changing the value of the function. So That's good enough because now negative over x squared dx is exactly du, so that's going to turn into a du. This negative we just kind of carry, that we can't do anything with it, you just got to carry it over. And then this is u, so e to the u. Now I'm sorry, but my u's tend to look like force, and my force tend to look like u, so I apologize for that. And then so we have the integral of e to the u. Now the negative will carry, right, and the integral of eu is eu plus c, because it's an indefinite integral. And so we come back and replace u with 1 over x, and that's it. All right, so one more. And again, I strongly emphasize again that you should guess that this would be your u, right? Your power. So let's go ahead with that approach. U is cosine of x. The derivative of cosine is negative sine of x times dx, right? That's your differential. And if we notice, we sort of kind of like the previous one, we have the sine x and we have the dx as a product, right? But we're missing the minus there. Not a problem, because we can always multiply by a constant. Think about it, you're multiplying by -1, but compensated by multiplying by -1, right? -1 times -1 becomes +1, right? So you will be back to the original. So then we take the negative sine of x times dx. That will turn to a du, right? And if you guys need some color here, think about that this right here and this right here, this product is exactly this right here, right? Which in turn is going to be your du. And then cosine will be the u, right? And the minus in front of it, it needs to be carried over. That's sort of it's now built into the problem. So it will be the integral of eu will be eu plus c, carry the negative, right? And replace back your u in terms of x. And so there you go. We found our u, our integral, right? Negative e to the cosine of x plus c. All right. So I hope you guys find this helpful. These additional practice problems, I recommend you guys even trying the same problem over and over, just for you guys to become familiar with the technique. Please let me know if you have any questions. I'll see you guys next time.